This is Math 139, and we're looking at Section 2.4D. One of the things that you've probably noticed as we've been solving these polynomial equations is that certain types of solutions always occur in pairs. Pairs that we're going to give a new language to, we're going to call them conjugate pairs. Whenever you do the quadratic formula, you always have that plus or minus just before the radical, which means that if you've got an irrational solution like a plus b squared root c, then because of the plus or minus in the quadratic formula, a minus b squared root c will also be one of the solutions, or one of the zeros. It happens with the imaginary answers as well. If a plus bi is a zero, then because it comes from the quadratic formula with the plus or minus in it, a minus bi is also going to be a zero. So these are what we call conjugate pairs. A plus square root of c and a minus square root of c are a conjugate pair. Similarly, a plus bi and a minus bi are called conjugate pairs. We can use that to our advantage. If we know something about the zeros of a particular polynomial, sometimes we can get more zeros just by using the idea of the conjugate pairs. So we're going to go ahead, and it says in these next examples, all of our answers should be polynomials, written in expanded form, and descending order. For starters, I would like a polynomial of the lowest possible degree, for which 3 is a zero of multiplicity 2, and the square root of 2 is a zero of multiplicity 1. Let's start with this idea. 3 is a zero of multiplicity 2. That means that our function, and I'm just going to write it as f of x, has to have x minus 3 as a factor, because by setting that equal to 0, we'd get an answer of 3. Now the fact that it's multiplicity 2 means there were actually two factors of x minus 3. I could have written it squared, but since I have to multiply it out eventually anyway, I'm going to leave it as x minus 3 times x minus 3. All right, next. 2, or square root of 2 rather, is a zero of multiplicity 1. If the square root of 2 is a zero, then the conjugate pair, negative square root 2, must also be a zero. And therefore, I will have x minus the square root of 2 as a factor, and also x minus a negative, or plus the square root of 2, as a factor. Now that doesn't look like my usual factored form. We don't usually factor with square roots, but we're going to multiply it out, so we'll see if we can get rid of some of that. I'm going to go ahead and just do them 2 at a time. X minus 3 times x minus 3 is x squared minus 3x minus 3x plus 9. Multiplying these together, I would get x squared plus x times the square root of 2, and then minus x times the square root of 2, minus the square root of 4. The first one is x squared minus 6x plus 9. And in the second one, I've got my x squared, but notice some really good things happen here. These two terms are opposites, so they add up to 0. And then the square root of 4 is just 2. So that just turns out to be x squared minus 2. Starting to look a bit better. Lastly, I'm going to multiply this trinomial times this binomial to get the expanded form. So I'll start by distributing the x squared. X to the fourth minus 2x squared. Next, I'll distribute the negative 6x. Negative 6x cubed plus 12x. And then finally, I'll distribute the 9 plus 9x squared minus 18. Combining like terms and also watching for that descending order, I'll start with x to the fourth. That's the only x to the third term I have, so negative 6x cubed. I have a couple of x squared terms. When I combine them, I'll have a plus 7x squared. And then I've got this plus 12x and that minus 18. And there is my polynomial that fits the given description. All right, let's try another one kind of similar. I want a polynomial of smallest possible degree. The zeros are 6i, 1, and negative 1. Just like the radicals, the imaginaries, anytime you have an imaginary, you also have its conjugate. So I'm going to make note to myself, negative 6i is also a 0, the conjugate. So when I go to write out my function, I'll have x minus 6i, but I'll also have an x plus 6i. I'll have x minus 1, and then also an x plus 1. Notice now if I were to set these all equal to 0 separately, I'd get exactly what I started with, back again. All right, once again, I'm going to multiply these out in pairs first. I will get x squared plus 6ix minus 6ix minus 36i squared. Over here, x squared plus x minus 1. All right, let's simplify a bit before we finish. We've got our x squared. Right, we do have our positive 6ix and our negative 6ix. Those add up to 0. And then remember here, what's I squared again? I squared is negative 1, right? So I've really got a negative 36 times a negative 1, or a plus 36. All right, in the second set of brackets, I once again get a little bit of a couple terms I can get rid of. They add up to 0. And I have x squared minus 1. Finally, let's multiply that out. Just binomial times binomials, so FOIL or double distributive law. And it looks like we're going to get x to the fourth plus 35x squared minus 36. Okay. So again, what we're really concentrating on here is if we have an imaginary or a radical as a solution or a 0, we automatically get the conjugate as well. Let's do one more. This time I'm told 0 is a 0 of multiplicity 3, and 4 plus I is also a 0, but of multiplicity 1. So right away I'm going to see 4 minus I is also a 0. there are those conjugates again. All right, so let's see here. My polynomial has x equals 0. It's a 0 of multiplicity 3. So I'd have x minus 0, or really just x. We'll simplify in the next step. But I had 3 of those. Then, my conjugates, I would have x minus 4 plus I. And I would also have x minus 4 minus I. Right? That way we'll get 0 3 times, 4 plus I once, and 4 minus I once. All right, x times x times x would be x to the third. And then I would have, if I just distribute the negative here, x minus 4, x minus 4 minus I, and x minus 4 plus I. I'm going to leave the x cubed where it is for right now, and I'm going to work on multiplying these two trinomials together, starting by distributing the x. So I'm going to distribute the x all the way through. Plus x squared minus 4x plus ix. Next, I'll distribute a negative 4. Negative 4x plus 16 minus 4i. Lastly, I'll distribute the minus I, minus ix plus 4i minus I squared. Sorry. So I had my x cubed to start with. I should have started my parentheses there. I don't know why I put a plus. And then all of this is what I got when I distributed and multiplied those two trinomials together. All right, let's see what we've really got here. I've got an x squared for sure. And then there are some things I can get rid of. Let's see. The positive ix and the negative ix add up to 0. The negative 4i and the positive 4i add up to 0. So that's all good. Then I've got a negative 4x and another negative 4x. So I have a negative 8x plus 16 minus, and that I squared I'm going to replace with a negative 1. So I have x squared minus 8x plus 17 inside my parentheses. And my last step is just to distribute the x cubed. So x to the 5th minus 8x to the 4th plus 17x cubed. All right, that brings us to the end of section 2.4.